Okay, let's continue on the SQL data definition language and a little bit more on the persistent programming module. Then that will be the end of the chapter here. So data definition language, actually, this is data manipulation language already. So after we create a table, alter, modify, change the table, putting all the constraint, now we are into this operation. Most of the operation, including insert, update, delete, and modify or update, change. So all these similar operation or retrieve, in this case, select statement. And starting with insert. So insert is simply as insert. So you insert into a particular table and you put the uh, the value and the column name and the value of that particular record in there, then you insert the record. Very straightforward. And if you open up the insert script from our previous example, you can also see a lot of these examples there. So let's move forward. And you can do bulk insert, meaning that, and this is usually done, actually, this is explained a little bit in chapter number 4, when we try to modify or select table from a non-normalized table to a normalized table. And you can select from a table and create multiple record insert. So we use insert into table combined with a select statement. You can create a bulk insert statement here. So you can actually become more efficient in data manipulation. So these are the basic data showing up in the database example from the VRG view valley ridge gallery example. Right? And other than insert, you can update. Update means changing the value. So you update something that you change the record, particular record, or a set of record to another value. So in this case, city is a column. So you change that value for that city column for the customer ID 1000. That's how you see that in. You can change multiple values as well. So very straightforward. You can update. So how do you do this in the database environment? Again, in most of the reason we are again not reading or writing this type of statement is because in the real database environment, and I'll cancel this operation. Go back to the inventory. What we are usually doing is you can, if you have a editing environment like this one, you can simply go into the uh, go into the data environment and click on edit, and you can actually modify directly in this environment. This is probably intuitive, more intuitive in the more intuitive in the SQL developer environment. So say for example, want to edit this 300, you can click on edit and change the value right here. Don't really need to enter the SQL statement here, even though that they do have corresponding SQL will be generated from the edit in here. So you can change that to description to something else, or stock keeping unit number to something else or something, doing editing from here. So I will not apply, I will not change the database for now. So this is how you can do it and in a more like a graphical user interface environment. But if you are using something more like a command line environment, like our PuTTY environment, then you probably need to use more of that command or data manipulation language you learn from the textbook. So that's the update statement. Edit, you're actually executing update statement. And you can update different kind of update value, and where statement is to limit. You can do bulk update as well. So when the city equal to Denver, all the area code will be updated to 303 in this case, right? Not only single column. Combined with a select statement, you can do bulk updating and as well, similar to insert in this particular example. A merge statement is sort of like I think the best way to understand merge in the SQL environment is in programming language we have this if then else statement. So merge is like if then else. So the only difference is the if then else is very limited in merge. It limited in a way that it only limited to either insert or replace or update. So when you use merge, you are looking at the record you try to put into the database. If the record is already exists, you can update the record. But if the data record does not exist, you can insert. So it's either insert or update, and you have if record exists, you insert. It does not exist, you insert. If the record does exist, you update. So that's uh, and the keyword used there is called a match. So it's kind of like an equal sign or logical statement equal in the programming language. Similar, but um, yeah. First, if you really get into the database operation, I'll probably ask you to do. But for our learning purpose, understand what this does is good enough, right? So this is one of the things. And when you try to modify or control the data integrity, editing the data value, then you need to use this particular statement. Right? So that's and finally you have delete statement that is dropping one row at a time, and you use delete. This is the only place we use delete in SQL language. Right? And SQL view we have seen that already, and I like to kind of explaining a little bit more about SQL view. Um, in SQL environment, in most of the database environment, we have another popular problem. And this popular problem, I think, if you read the text, they will describe in terms of security. Most of the database application has a security threat called the SQL injection threat. And the best way to avoid SQL injection is use database view. And this is the application of view you can solve this typical in database because in a lot of this application in real world we need to grab our data from multiple sources, and view can hide the complexity of the true table query. So when you create a view first and then query from the view, you can create the application much easier and the performance will be much better. So that is actually the purpose here. And the language structure, you see this already, create view and combine with a select statement. View is by definition, is a dynamic set of a table. So it does not actually occupy the memory space unless you cache the view. But so it's actually a small subset of a table. So what is a subset of a table? Whatever you select from the table is a subset of the table. So that's why that view. One interesting thing is that view does not support order by clause. So you need to use some other mechanism to sort the record from the view. Maybe sort before you create a view. Then it will be a good idea. Right, so this is create view statement. Then you can some example. And view can be altered as well, just like table. So you can create view, alter view, or create or replace, and all these are the programming part of view. And this is part of the thing that probably we need to pay a little bit more attention is where and why are we going to be using view in our database management. One is when you try to hide column or view for security purpose. Say, for example, you want your employee to research on and say if I ask my graduate assistant to research on my student performance, and so I want her or he or her, him or her, try to calculate say that average midterm score for my class. But I don't want to give the graduate assistant the entire grading table or the entire grade for my class. I can create a view so the graduate assistant does not see the student name, but he or she will can see the score, the exam score column. That is one of the purpose, hiding column or view. Or display the result of a computation. Example, we use in learning select statement. I show you that already. High complicated syntax and building functions and so on and so forth. So these are the basic uh, purpose of why we are using Vue. Very powerful. Actually, the Vue is one of the things I found as a data analyst. It's probably the most commonly used feature. Uh, Probably even more than the store procedure that many of the DBA like to use is Vue. And one of the Vue, because Vue is usually used for report generating purpose. So when you have a view you want to update the value, that is actually not recommended usually. So and there's some reasoning and condition that you can change the value called updatable view, usually in a single table view. But a short recommendation here is try not to use updatable view unless you are very sure. But usually we recommend not to, right? Not to. But this is a possible situation there. It's available over there. And learning SQL language for developer, you can embed the SQL language in your programming language. So a lot of this computer science people, they will just issue a select statement in their Java program or C# program, grab the data and do all the computation over there. Or you can do a lot of computation and programming here. So now we're getting to this software architecture discussion. And earlier I used the terminology application layer, database layer. You probably heard about this called user interface layer, and some other place will have middleware layer, internet layer, a lot of layers. Each layer can perform certain job, and the decision on what you should be doing at which layer now become the decision of the developer, the designer. So again, the recommendation is put more database operation in the database layer, right? Do not put this into the application layer. But again, if you become a higher level or middle level IT manager, then you can probably pay more attention to this because most of programmer they like to put a lot of computation at application layer. That is actually a bad practice. You want to make sure that application layer will do more on maybe computation, but is actually after you done data summary, then you do limited computation. Maybe you can do something more. I mean, application layer do some more complicated algorithm, but not to process data. Right. So that's the recommendation here. Usually, whenever the database programming language, database engine can do not give it to programming language. Right. So the example can be used in different programming language. This is a part different type of environment will have different standard. So Microsoft will use one standard, and Oracle will be using another. And since we're not writing program here, learning this will be good enough. The other sort of like just mentioned here importance difference between programming language and database table is programming language is straightforward. If you want, and database is stored in table, and table are usually two-dimensional, column and row. So when you move the database table into a programming environment, the programming environment usually need to create a two-dimensional linked list or matrix or array, two-dimensional array to handle the table. And so this is where that the programming in programming language is different from the SQL language. To handle multidimensional processing, SQL is slightly easier. But if you are used to the programming logic, you may create some problem as well. The key to understand this is that every time you use database SQL language to process table, you need to create this thing called a cursor. The cursor is pointing to where your data is running right now, and you usually go one row at a time, not one cell at a time, right? One row has multiple cells, not one cell at a time, but one row at a time. used in database environment. And database, again, as I mentioned in the previous lecture, that it's building into some sort of programming language capability. It's in general called the persistent store module, but it's called different language in different environment. Microsoft called this Transact SQL or T-SQL. Oracle called this PL SQL, Procedure Language SQL. PL SQL, Transact SQL. They use slightly different keywords in these two languages. And the PL SQL or Transact SQL create three different objects: function, store procedure, and trigger. And in our lecture in this class, we will not go into too much detail, but I will create some example, as I mentioned at the end of your semester, to let you know how these are used. But for our lecture purpose, I just want you to know that we have these three types. The function, user-defined function, right? Just like the function you use in select statement. If you have something that you want to use, you can create this to perform calculation that is not provided by the default library from the vendor. To perform some, in this case, they are trying to combine two names together to create a name called a customer, because the data was originally stored in first name one column, last name one column. So like they kind of create a simple function, combine two names, and create this. So this user-defined function. And you can have trigger. Trigger is usually something that automatically run when you try to perform database operation. And in different environment, there are different type of trigger. Trigger usually have three different type. Before a certain thing happen, usually insert, update, delete. Before insert, update, delete, you have before trigger. You have instead of trigger, you replace that original operation, or you have after trigger. Right? From end user's perspective, you don't see that much differences, and this is why in different environment they implement the trigger differently. Say for example, in the Oracle environment, they have insert before, insert instead of, insert after. All the three different type, 9 different type of trigger actually already. But in Microsoft SQL Server, they do not offer before trigger. So they do not offer anything before trigger. The before and after has some slight small implication on how the data record is created or deleted. But from the end user's perspective, is that if the transaction is carried out, it does not really make too much differences, right? So that's why Microsoft decided not to use the before trigger, right? But from the SQL standard, there are 9 different trigger. The 3 different type combined with 3 different action create 9 different trigger in the function. And the purpose of trigger: provide default value, enforce constraint, update view, or perform some sort of integrity check. So data quality become an issue when you try to use trigger. Because when will the data quality problem arise? Insert, delete, update, right? That's called a DUI anomaly. So whenever you try to do something in database, insert, delete, update, you write a small program to double check. That's called trigger to check data integrity. And finally, that we have store procedure. Store procedure are now usually used by database administrator to provide access to a database to programmer. One of the reasons that I mentioned earlier, security reason, when a developer tries to develop a commercial program for your database, a lot of time you don't want a developer to know the content of the database. You want the developer to know the structure of the database, but not content, because you don't want a developer to steal your customer or employee data, right? So in order to do that, you write a store procedure to hide your data. So when the developer need data, they use a store procedure. They don't see the table directly. Right? You can do that through a view as well. So either view or store procedure depends on how complicated the data. Typically, when you have data restored from multiple databases and multiple table, you use a store procedure. If this is coming from a single table single database, then use a view will be sufficient. So view store procedure provide a doorway for the programmer developer to use your data without being exposed to the real content of your data. Right? So you can use store procedure, but usually, as far as my experience goes, that it's used for the providing the entry of a database for the developer to use your data. Right? And sometimes it's used together with the developer to create a combined program. Part of the calculation function are done in programming language application layer. Part of this is done by database engine. This can sometimes balance the load because every time you do some calculation, data retrieving, you are talking about the computer need to do the job, right? So now you're using your own computer. I'm using my computer. Our communications go through a server. So how the three computer different, my computer, the server computer, and your computer need to do what kind of job is the discussion of how you're going to be designing the software architecture, right? So usually we try to balance the load. Your own client computer will do some computation. My computer will do some upload inputting, and server will create some sort of segmentations and performance tuning on cloud. So that will divide the job and try to make sure the delivery of the content from one end of the system to the other end more or less smoothly and efficient and with a good performance measurement. Right? So that's pretty much it. And we have kind of gone through the uh, SQL language introduced in a much more detail compared to from the beginning of the semester when we only learned the data retrieving language or the select statement. Now we are learning a lot more, and you know that SQL is powerful enough to be a semi-programming tool to create a reasonable data processing program. And actually, the modern day called it data mining, and of course, people will buy specialized software, IBM SAS, SPSS, or some of the data mining tools, R language, and so on and so forth to perform data mining. The database engine actually can perform a lot of data mining already. And if you go to our Oracle Apex website, you can search for the called the database analytics. So using database to perform analytic job, they have a complete tutorial out there to teach you how to do that. But again, in today's learning environment, there are always resources out there, free, available. You just need to search through Google. But going through the university, we are creating a mechanism to force this upon you, so you can be uh, pushed and learn and memorize all these important features. Minimally, you will remember some of the things we say here, and when you need to use them, you can come back, drop the email to me, and I'll tell you where to find resource or new development. Sometimes it will be new engine and new environment like Apex to solve your needs and problem in your organization. All right, so that's the lecture on chapter number 7. I will stop the recording at this minutes.